Hello everyone, this is the third clip for day 28 and I want to talk about how to find binomial probability values in the table that I've posted on Canvas. So let's say we toss a coin 6 times and want to find out the probability to get exactly 5 heads, 5 times heads out of 6. So that's binomial probability formula. We look up the table, and the first thing is we need to identify the probability to get heads in one coin toss. That's obviously 0.5. And we always write this as a lowercase p, 0.5. And you see these given at the top of each of those tables. So that's not the right table. Scroll, scroll. There is 0.3.5. We need this table. Next thing, we have 6 coin tosses. That's the n. Like lowercase n. And in the table, this is the row labeled with a 6 right here. So let's put a little arrow here. This row is what I'm talking about. Next, we need to identify the right column. We have 5 out of 6 heads, and that's what I always call K. K is 5. That gives us the column. You see that labeled K, and it's the 5, the first column. So okay, it's only fifth column if you start counting at 0, but you can put an arrow right here. And so we need to find this number in the row with the label 6, column label 5, it's the 9.375. I'll put a rectangle around that number. And we can write probability of k is 5 given that n is 6 and p is 0.5 is 9.375 in percent. That's important. So you can also write 0.09375. Next example. Let's say still coin toss, 10 coin tosses, and the probability of getting at least 8 heads. So probability for heads in one coin toss is the same thing, no change there, 0.5. We still need to look at the same table that we have right here. But this time n is 10. And To get at least 8, we just need to add up the 8, the 9, and the 10 probability. So k greater equal 8 means p of 8, or we can be more specific, p of k equals 8 plus p of k equals 9 plus p of k equals 10. Where do we find those three numbers? We find them in the same table in a row with the label 10 and under the column headings 8, 9, and 10. So I can put some rectangles around them. Let's see, a green one. That's my first one. And a yellow. That's the probability for 9 heads. And that last one is the probability for 10 heads out of 10 coin tosses. It's possible. Of course, quite unlikely. We can grab these numbers and add them up. I'm going to just round it to 1 decimal digit. So that's 4.4 plus 1.0 plus 0.1, which is 5.5, and this is in percent. That is in script 27, an example which you will have recognized, I hope. All right, one more thing, an example about rolling dice. We want the probability of rolling not a 6. Probability for doing that 4 out of 7 times. So P, lowercase p, is the probability to roll not a 6 in one roll of the dice. That's 5 out of 6. And if you look for the table, you can't find one. I didn't do a table for that. So what do? The probability of rolling not a 6 4 out of 7 times is the same thing as rolling a 6 exactly 3 out of 7. And now we're in business, because for rolling a 6 we have the probability lowercase p is 1 over 6. The n is 7, and the k is 3. We can look that up real quick. So we need to find the right table. Here's the correct value for the lowercase p. And then we need to find row with label 7 and column with the label 3. So that brings me right here. I just got 7.8143%. All right, that's how you can find those values in tables. It should be a huge time saver. Once you got the hang of it, you don't want to go back to the calculator, especially when you want to calculate a number of them in the same row for the at least questions. I hope you get that sorted out before the exam and you'll be fine. Thank you, and that's it for today.